Hello friends, again here I am with another question of indefinite integration that we're going to solve by the substitution method, but it's a little bit more difficult than the previous one because we don't have the derivative of any expressions present itself in the integrand, right? Our independent variable containing term is cot x, or you say 1 plus cot x, but the derivative of 1 plus cot x is minus cos x square x, which is not present here. It means we have to simplify this, we have to work on this so that the expression itself will contain the derivative of the new function that we're going to introduce later in the integrand itself. All right. So what we can do, we can't work except putting the value of cot x, that is cos x over sin x. There's a ratio of cos x and sin x, so it's dx, and it's 1 plus cosine of x divided by sine of x. All right. Further, what we can do, this sin x will multiply 1, so it's gonna be first I'm writing this sin x plus cosine of x, and divided by this sin x is here, but that I can put at numerator as like this, sin x dx. And further, what we can do, can we substitute now? The derivative of sin x is cos x, which is not present here, and derivative of cos x is sin x, which is present here, but this sin x will left and it will be t plus 1. Again, it's not gonna work, we need to work more. Okay, so what we can do now, I have an idea. Let's multiply by 2 sin x. All right, we can write the derivative of sin x plus cos x itself right here. You know, the derivative of sin x is cos x, and derivative of cos x is negative sin x. Am I right? So we have sin x here. We can make this itself present here. See how I multiplied by 2 and I'm going to divide by 2. All right, and then this is sin x plus cos x times dx it is, and further see, it's 1 by 2. All right, now derivative of sin x is cosine of x, and derivative of cosine of x is negative sine of x. My dear friend, what I'm going to do, take a look very seriously. I'm going to multiply here by minus, and I'm going to multiply here by minus. Okay, and now see, cosine of x I have written myself, so I'm writing negative cosine of x so that I can cancel, and negative sin x it is, so again I need to put here negative sin x over minus, because it was minus 2 sin x, you know, so minus sin x minus sin x minus 2 sin x, no problem at all, and minus 2, let me put here again, and then divided by sin x plus cos x and times dx. Further, minus half, right, cos x minus sin x. Now I'm going to take this as one term and this whole as another term. So first time, let me write that cos x minus sin x divided by sin x plus cosine of x dx. All right, we finish with that term. Now here is also minus, here is also minus. All right, so I'm gonna take negative as a common, and you know, this minus will again multiply this. Let me first show you that when I will take negative common, then I will get cosine of x plus sine of x dx divided by sin x. See, here is sin x plus cos x, so you can exchange, like, you know, the first you can write cos x and then you can write sin x. That's not a big issue, like writing a plus b and b plus a, that same thing. And now, my dear friend, this minus half will multiply these terms also, you know, after taking the negative. If you take negative here common, then it will be plus, and that negative will multiply this negative and it will be plus. Okay, and I think I forget to write this half. Okay, this half is here. So our question is turning something like this. Our integral is now negative of half cosine of x minus sine of x divided by sine x plus cosine of x dx plus half dx, because there is nothing left, just 1. And now we can substitute the value, because the derivative of sine x is present here, cosine of x, derivative of cosine of x is negative sine x, which is here. It means our new function t is equals to sine x plus cosine of x, and differentiation of t with respect to x will be cosine of x minus sine x. and the relationship we're going to build up is dt equals to cosine of x minus sine x times dx. Alright, so this relationship I'm going to use here for this expression, and my integral is converting as a minus half cos x minus sin x dx. Cos x minus sin x dx, that's simply dt. Alright, it's dt and then divided by sin x plus cos x, that is again t. Alright, and this is plus half antiderivative of 1, that is simply x, and we always have to put a constant. Okay, and again minus half, and again integration of 1 by t with respect to t, that's log of absolute value of t plus again half x plus constant 1, and let me put the value of t originally. The original value of t is sin x plus cos x, so it's half, negative half log sin x plus cosine of x absolute sign, alright, plus x by 2, and plus here also we need to put constant, I forget constant 2, and this constant 2 and constant 1 together makes another, because this another constant, these all are arbitrary constants, so it doesn't matter, and this was our solution.